Now we're going to be learning about vector components. I think I'll do a little lecture on it later, but I think it's better just to jump right in. So a car travels 20 kilometers due north and then 35 kilometers in a direction 40 degrees north of west. Find the magnitude and direction of the car's resultant displacement. Let's start by drawing it out. When we draw it out, you'll see why we have to use components and can't simply use Pythagoras and the inverse tangent. First, we'll draw a compass. One thing I don't think I've mentioned yet is whether each direction is positive or negative. So east is going to be the positive x direction. West is going to be the negative x direction. North is the positive y direction. And south is the negative y direction. So then we'll draw where the car actually goes. Let's say the car starts here, goes 20 kilometers north. One thing I haven't mentioned before is that it's good to draw an arrow for the direction that the object goes. That way it's easier to visualize the vectors. Okay, and then the car goes 35 kilometers in a direction 40 degrees north of west. So what would that look like? Well, this line that I just drew is our western line, and then this line that I drew right here is our northern line. It says the car goes 40 degrees north of west. So 40 degrees north of west would be like this, and then 40 degrees above that. So that would look something like that. And that's 35 kilometers. Now, you see right away why we can't use Pythagoras. It's because this triangle is not a right triangle. However, you may notice, and this red line that I'm drawing here is the vector we're trying to find, the displacement. You may notice that this red triangle that I'm drawing is a right triangle. So the object of vector components is to find out how far the object goes in the x direction and how far the object goes in the y direction. So in this case, the car has gone this far to the west, so that would be the x direction, and then this far north, that would be the y direction. Now, what we have to do is break up each of our vectors into x and y components. We have two vectors here. We've got the 20 kilometers and the 35 kilometers. And let's make sure we go back and label this angle. So let's label these vectors. I usually label them with letters of the alphabet. I'm going to call this vector A and this vector B. Let's start with vector A, breaking it up into components. Now, vector A. Does vector A go off in the x direction at all? Well, the answer to that is no. It goes straight up north, doesn't veer off to the left or to the right at all. So the x component of A is going to be 0. How about the y component of A? Does vector A go in the y direction at all? And the answer to that is yes, it does. It goes positive 20 kilometers. So we just write 20 here. So that was the easy part. Now we have to find the components of vector b. So let's see if we can figure out what the x component of b is. We have to ask ourselves, does this vector go off in the x direction at all? And the answer to that is yes. I'm going to switch colors here so you can see it a little bit more clearly. Watch for the blue. It goes that far in the negative x direction. Okay, so we're trying to figure out bx. This side right here is bx. How would we figure that out? Well, we can use our trig functions. We know the hypotenuse, and we're trying to figure out the adjacent. So what trig function do we want to use there? Well, we don't want to use sine because that would be opposite in hypotenuse. We want to use cosine because that's the trig function that involves the adjacent and the hypotenuse. So we come up with this expression. I'm going to write it over here in blue, that the cosine of 40 degrees is going to equal bx over 35, that 35 being the hypotenuse. Then we can just solve this for bx, and we come up with bx equals 35 cosine 40 degrees. And actually, if you guys notice, I forgot something here. We have to remember that since this guy is going west, it's going to end up being negative. So let's make this a negative bx here so we can remind ourselves to put that negative in later. That's going to end up being important. All right, so let's write bx equals negative 35 cosine 40 degrees. We'll plug that into our calculators later. All right, let's look at by. Does this vector go off in the y direction at all? And the answer to that is yes. It goes this much in the y direction. So that's by. In this case, we want to use the sine function to solve for by. And the reason for that is that by is opposite and we have our hypotenuse. So we're going to set up a new expression. Sine of 40 degrees is opposite over hypotenuse, so by over 35. Then we'll solve for by, and we'll say that by is 35 times the sine of 40 degrees. And we can write that here. Okay, why don't we need a negative for the by? Well, the answer is that this car is going overall north. And remember, north is the positive y. So that's why the y component of b remains positive. Okay, so let's actually solve these out. If you plug these into your calculator, bx will end up being negative 26.812, and by is going to end up being 22.498. So now what we've done is we found out overall how far the car goes in the x direction and how far it goes in the y direction. We just have to actually add them together. Now when we add them together, I usually call that the next letter in the alphabet, which in this case is C. So the x component of C is going to be 0 plus negative 26.812. That's just how overall how far the car goes in the x direction. And then cy is going to be 20 plus 22.498. which is 42.498. Again, that's how far overall it went in the y direction, because remember, when it went 20 kilometers north, and then it went another 22.498 kilometers north when it did the 35 kilometers in the direction 40 degrees. So what we've just found is this line, which is negative 26.812, and we found this line, which is 42.498. So, as you can see, and what we're looking for is the hypotenuse of the triangle. So you can see that we can easily use the Pythagorean theorem. So the magnitude of C is going to be equal to the square root of cx squared plus cy squared. And again, that just comes from Pythagoras. A squared plus b squared equals c squared. In this case, a is the x component and b is the y component. So let's go ahead and plug these in. C is going to be equal to the square root of negative 26.812 squared plus 42.498 squared. Assuming you can plug that into your calculators correctly. And if you do, you should get 50.249. Let's write in our units. In this case, our units are kilometers. All right, so what we just found is the magnitude of our vector. We still need to find the direction. In this case, I'm going to switch colors here, switch to purple. We're trying to find this angle. Now, you should see that it's actually pretty easy for us to find that angle now. We know this whole y component, cy, and we know this whole x component, cx. You should be able to see that we can just use the tangent function, opposite over adjacent. So, you should get that the tangent of the angle is equal to cy over cx. So the angle is going to end up being equal to the inverse tangent of cy over cx. Now when you're finding the angle, you don't actually have to worry about the negatives here because we're going to add in direction words. The direction words will tell you whether it's positive or negative. You'll see what I mean in just a minute. So let's go ahead and solve for our angle. So our angle is going to be equal to the inverse tangent of 42.498 divided by 26.812. And you should get 57.75 degrees. Okay, now we have to add in our direction words. What should our direction words be? Well, this line right here is our western line. So overall, the car went a certain amount of degrees north of west. We just figured out the degrees, 57.75. So our direction words are north of west. So let's circle our final answer. And there we have it.